Solar is wonderfully predictable, like given the sun's position, given the orientation of the array, given all of these physical factors, this is how much energy a system should be producing. You can model that. Like you can, generate a weather adjusted simulation and kind of have like a good, you can make a very good prediction for how a system should be performing at any given point in time. Batteries make things more complicated because batteries are generally set up to operate dynamically based on how much energy the customer is using. So, for example, in most utility jurisdictions, the battery is supposed to charge from excess solar. So, charge whenever the customer is not using all of the solar energy that's being produced, and then discharge whenever the customer might need to draw from the utility grid. And so to understand when to charge and discharge, the battery needs to understand how much solar energy the customer is producing, and they need to understand how much energy the home is consuming. So where this gets complicated is, the solar power systems generally, they measure how much energy they produce. So you have that number, you know how much energy the system is going to produce. That's not more complicated, but the monitoring gets significantly more complicated when you're trying to measure the consumption of the home. Most homes in the US are split phase homes, meaning they have two lines of electrical service in the home to measure how much power is flowing to the home. You have to have a sensor called a current transformer, or CT. You have to have, they look like little plastic donuts, and you have to have two of them in very specific places within the customer's electric panel, main service electric panel. And those donuts have to be facing the correct direction. They have to be in the correct location on the wire. And then from there are two wires that the current transformers need to be connected to the metering device. Those two wires need to be in the correct inputs in the meter. So suffice to say, it's very, very easy to not install those CTs correctly, to get them backwards, either that because you've got the leads flipped in the meter, or the donut is in the wrong spot, or the donut is backwards. The other thing that we're seeing that's, I think, very related to this is we're now seeing certain configurations where customers are getting a second system. This is happening a lot in California, where there's a lot of market penetration. So the customer's getting like a second, they call it a non-export system, or we'll call this a multi-tariff system. And so now the customer has an existing solar power system and a new system, and this requires an additional set of CTs. So the installers are responsible for installing 4 CTs and getting every CT in the right location to be able to monitor the power. And there's other stuff associated with this. Like each CT has a ratio factor. And so all of the data coming from these current transformers needs to be multiplied by a certain number based on the spec of that transformer. The installer's got to put that number into an app. They've got to configure it. And there's just a lot of ways that it gets more and more complicated. And then I think this is maybe related to performance, but for those non-export systems, the solar power system actually has to curtail itself or shut off because it's generally not allowed to backfeed through the utility meter.